Alright, welcome to naming worksheet number 3. Here you'll see some video solutions to how to solve some of the problems. Main focus here will be with ionic compounds that have polyatomic ions, and we'll also use some of the previous worksheet stuff which dealt with binary compounds. Alright, so when writing names or formulas for ionic compounds, okay, so key here is ionic compounds. Ionic compounds always have a metal or ammonium, this chemical formula, first, and then a nonmetal second. So if you ever see that combination, metal and a nonmetal, or ammonium and then some nonmetals, these are going to be ionic compounds. Make sure you follow the ionic system for naming. So here we go. Alright, so first thing you want to do is always draw a line here. We're trying to figure out the names. So you draw a line, and then when you see that it's a metal and a nonmetal, it's an ionic compound. So now you got to figure out the charge of the anion and then the cation. So find the charges. So the second thing, you will always be able to find the second page of your gold packet, which looks like this. And C2H3O2 with a minus charge is called acetate. Okay, so it's got a minus charge. To figure out the charge of the other thing there's a way to go about it, but sodium is one of those things you should always know, because sodium, find a periodic table here, sodium is always in group 1, and its charge is always going to be +1. So group 1 is always 1 plus. So for those metals that have an absolute charge, it's always going to be this, it's always going to be this. Those ones, you can just go with them. You don't need to do anything. Also, because it's the only charge they can be, they don't need a Roman numeral. So, sodium plus, and when we name this thing, you just say it like it looks. Sodium acetate. Alright, the next one, 2b. You draw a line, look up what the second thing is, find the charge of that thing, and that second thing is NO3. It's got a minus charge, it's called nitrate versus nitrite. And the first thing that should look familiar, that thing is ammonium. I'll go show you on the periodic table really quick, or on the gold packet. Ammonium is NH4 with a positive charge. So you can see the charge of both those things equal each other out. Now you just write the name, put it together. It's called ammonium nitrate. Alright. 2C. Draw a line and see it's a metal and a nonmetal, so it's ionic. So find the charge of those things. CO3 has a 2 minus charge and is called carbonate. So 2 minus. Calcium there, if you look that thing up, calcium is in group 2 on the periodic table. It's right here. So therefore, it always has that charge, nothing else, so it's not going to need a Roman numeral, and we can just mosey on here. So this is going to be called calcium carbonate. Carbonate. I can't spell today. Carbonate. Alright, moving on. Okay, number 3, we're still trying to put names together here. First thing you need to do, draw a line. Look up the second thing on the second page and see what its charge is. And Cn minus is right here, and it's called cyanide. So it's Cn minus. Cadmium here, let's look up, I know what it is. Cd is right here in the periodic table, and it's always got a charge of +2, so we don't need a Roman numeral here. So we can just name this thing like it looks. This is called cadmium cyanide. Okay, next one. Okay, we draw a line. See, it's a metal, nonmetal, it's ionic, so find the charge of the second thing. And SO4 2 minus right here is called sulfate. So put a 2 minus here. Hg, gotta look what that is, and Hg is mercury right there. And mercury has more than one charge, so we need to figure out which one it is. And then we also need a Roman numeral then to specify which one it is. So if you have one of these, and the charge is 2 minus, on only one of these, it must be 2 plus to balance off the charge. And now because it's mercury with a 2 plus charge, we do need a Roman numeral to specify that it is mercury Roman numeral 2. The Roman numeral is the charge, like so. 3C. First thing you do is draw a line. can see it's metal and non-metal, so look up what the charges are in your gold packet and periodic table. So ASO4 is over here, and it's got a 3 minus charge. It's called arsenate. Okay, arsenate, it's 3 minus. Let's look up what magnesium is quick, see if we need Roman numerals. Magnesium on the left-hand side of the periodic table, it's got a 2 plus charge, and that's it. So it does not need a Roman numeral. We can just name what this thing is right now. So it's going to be called magnesium arsenate. Good. Alright, and number 4a, first thing we always do is draw a line. And you see ammonium is first, so it's definitely going to be a ionic compound. Look up the second thing, find its charge. Second thing is C2O4, 2 minus charge, and it's called oxalate. And then the first thing there is ammonium, NH4 with a positive charge. And there's 2 of them to balance off this charge. So technically the charge on the left side is +2. Charge on the right side is also, but -2, and it balances. So naming this thing outright, it's just called ammonium, UM at the end, oxalate. Number 4, letter B. First thing you do, draw a line, find out what PO4 is, second thing, second page, and PO4 has a 3 minus charge and it's called phosphate. So 3 minus and it's called phosphate. Iron, yay, iron. Look it up. Iron's right here, and you can see it has more than 1 charge, so it will need Roman numerals. We also need to figure out which one it is. So iron here, there's one of these, which is -3 for overall charge. This side must balance it, so it must be +3. And 1 iron must be a 3 plus charge to make this particular compound neutral. So this particular molecule is called, or this particular substance is called iron Roman numeral 3 phosphate. I want you to notice that the Roman numeral does not indicate how many of something there are. It indicates the charge of that metal ion. A lot of students think it means how many there are and make that mistake. Number 4C, first thing you do, draw a line, metal, non-metal, ionic compound, so find the ion charges. So we're looking for ClO. Notice the 2 is on the outside, so it means that there's 2 of the thing inside. So we're looking for just ClO. So second thing, second page, and ClO is right here. It's got a minus charge and it's called hypochlorite. Minus charge. Let's check out what zinc is for a charge. And zinc's only charge is +2. This one does not need a Roman numeral. So you just put the 2 names together. It's called zinc hypochlorite. Alright, good job so far. Number 5, now we're going the other direction. We're going to try to make the chemical formula. Just like before, you draw a line to separate. So you find your first word, draw a line afterwards. You see it's a metal and a non-metal or polyatomic ion, so look them up. So what's nice about Roman numerals, remember, that's the charge. So if you know that copper is Cu, this tells us the charge. You don't have to look it up. So it's Cu plus. Carbonate, though, let's look that up. It's on the second page. And carbonate is CO3, 2 minus. So basically, you write down the symbol and charge of both things, and then when you're all done, you will crisscross and simplify. So technically, a 1 is right here, and that crosses over and does nothing. So we have just 1 CO3. The 2, not the minus, but just the 2 crosses over, and now we have Cu, 2 CO3. That is the chemical formula for copper 1 carbonate. 5b. First we draw a line. We see it's made of a metal and a non-metal, so it's an ionic compound. So find the symbol and charge of both of those ions, and then crisscross and simplify when you're done. So looking up silver. Silver is right here. It's Ag, and it's got a +1, and that's it. That's probably why it doesn't have a Roman numeral. It's only got a +1 charge. Iodate, second thing, second page, and iodate is right here. It's IO3 minus. IO3 minus. When the symbols or the charges there are equal but opposite, you don't need to crisscross. So just sliding this together will make the neutral compound of iO3. Good. 5C. First you draw a line. It's a metal and a non-metal, like everything on this worksheet. So find out what the ion charges are for this ionic compound, and then crisscross simplify. So chromium, I recall, is Cr, and the Roman numeral is the charge, which is really nice, so it's Cr3+. And then sulfate, second thing, second page, you look up sulfite, it's SO3 with a 2- charge. So SO3, 2-. A little crazier to crisscross this one. The 3 is going to cross over here. The 2 crosses over, and don't forget, we don't really care about the charges anymore. It's just the 3 and the 2 crisscross. So to clean it up, you end up with Cr2, SO3, and that 3 crosses over. But you want to say there's 3 of this, so you put that in parentheses. It's really important you do that. And then don't go ahead and distribute to the 3 everything. You want to leave it like that, because leaving it like this, when I see SO3, SO3 is sulfite. So make sure you always keep the polyatomic ion intact so you can tell what it is. Good. Number 6. Here we're going to draw a line. You can see it's a metal atom and a non-metal combination there, so it's an ionic compound. Find the charges and crisscross simplify. Lithium. Now, as you start to get better at these, lithium, you should maybe know is on the first period of the first group of the periodic table without even looking. Okay, let's confirm quick though for those doubters out there. There's lithium right here. It's a 1+ charge. That's it. Perbromate. Second thing, second page. Perbromate is right here. It's BrO4-. So, as you can see, the charges are equal but opposite. +1, -1. Just stick it together. It is LiBrO4. That's it. Number 6, B. First thing you do when you see a compound, draw a line. Then, when you see it's a metal and a non-metal, you can tell it's an ionic compound, so find the ion charges and crisscross simplify. So tin, you know, that one's a trickier one, but looking over the periodic table, tin is right here, number 50. And it does have more than one charge. That's why it has a Roman numeral indicated. And remember, the charge is the Roman numeral. Sn, though, is tin, Latin for stannous. So tin is going to be Sn2+. Roman numeral is the charge. Not how many, but it's the charge. Dichromate is the second thing. So we'll go to the second page. And dichromate is right here. Cr2O7, 2-. That one's a little crazier. Again, though, what's really nice here is both these things have equal but opposite charges, so just stick them together. Sn, Cr2O7, and that's it. So there is no need to crisscross simplify when they're the same thing. So if you did crisscross them, the 2's would crisscross, and they'd simplify down to 1 and 1, like our formulas already. Alright, 6C is called cesium permanganate. You draw a line to separate the two things. Cesium is a metal, permanganate is a non-metal, it's ionic. Find the charges. So, cesium is right down here, group 6, period 6, group 1. Cs got a 1+ charge. And then permanganate can be found right there, and it's MnO4-. And this was a nice page here because everything was equal and opposite for charge, so you just stick them together. Cs, MnO4. Okay, this isn't too bad. Okay, last part of the first page, we have number 7A. So here we have a compound. You're going to draw a line to separate it. It's bismuth 5 fluoride. Bismuth, if you recall, is Bi, so we'll double check that though. Right down here, number 83, Bi, and the Roman numeral is 5, so it means it's got a charge of 5, so Bi 5+. And then fluoride. Fluoride, you should kind of know that one. That's in group 17, the halogens. And the halogens are all 1-. Okay? So fluoride's going to be F-. Also, these are in your goal packet. The second thing is always on the second page. If I scroll up a little bit here, Here's all the non-polyatomics. So it's just an element. So arsenide, phosphide, sulfide. Here's fluoride, chloride, bromide, iodide, oxide, all the way to telluride. When they're negatively charged, they end with "ide." The nonmetals do. Okay, but fluoride's in group 17, so we should really know that that's going to be a -1 charge. All right, so it's F minus. Crisscross and simplify, and you end up with BiF5. Number 7b. Number 7b is ammonium hydroxide. So you draw a line to separate it. You see the word ammonium, right off the bat you know ammonium. Ammonia, by the way, is NH3. Ammonium is NH4 with a plus. So it's an ionic compound because it's got to charge something. Second thing, second page, hydroxide is down a little ways in the left column. It's OH minus hydroxide. So we have OH minus, equal and opposite charges, just stick them together. NH4OH is ammonium hydroxide. And lastly on the first page, we have 7c, draw a line, metal and a non-metal. Look up the charges, or look up the symbols and charges here. Lead 2, lead, I'm not going to look up, is Pb on the periodic table. And the Roman numeral is the charge, so it's Pb2 plus. Nitrate though, second thing, second page. And by the way, you will get to know these a little better, so don't worry if they're coming kind of slowly here. But nitrate is right here, it's NO3 minus. Not the first time we've seen this one. And then they're not equal and opposite, so we're going to crisscross the 2, and then crisscross technically a 1 here over. 1s don't do anything, so you end up with Pb, and then it's NO3, and parentheses are around that, and the 2 is on the outside to say there's 2 of this. Okay, so the 2 comes over here, and you put parentheses around it. This is lead 2 nitrate. Good job.